Good morning. In today's lesson, we're going to be talking about unit rates, and our two learning goals are that we are going to estimate and calculate values that use unit rates, and then we're going to use unit rates to determine what is the better buy. And this is going to be a great real-life application for reasons like this. It says, when you buy something on sale, do you actually go and calculate the discount yourself, or do you just let the store calculate it for you? And some of us might say, oh my gosh, well, they have the cash registers and computers to do it for you, so why not just let them do it? Well, sometimes they make mistakes, first of all, and secondly, sometimes there are a lot of shady people out there that actually do the wrong thing. So it's really good for you to have some kind of a good sense of number sense so that you know, is the store actually doing right by you or not? And we're going to start that conversation by looking at problem number 1. And in problem number 1, it says that Marta and Brad are going to the store to buy some detergent. They see that the brand he wants comes in 2 different sizes. So you can get 26 ounces for $9.75, or you can get 20.5 ounces for $7.50. So it's asking which one they should buy. Right now, we don't necessarily have to have the best, for lack of a better term, mathy reason. You certainly can if you want to. If you're like I used to be, you might just go ahead and automatically buy this bigger one because you think, oh, well, that's the way stores do it. The bigger the boxes that you buy, the cheaper it is because they charge you less per ounce. I certainly used to believe that until I discovered once I became a grown-up that that's not necessarily the case. Some people might do what this guy says and says, shouldn't you just buy the cheaper one? I'm just going to pay for this one because it's $7.50, whereas the other one is $9.75. A lot of people would disagree with that, though, because while this one is cheaper because it's only $7.50, you're only getting 20 ounces, whereas in this other one, you're getting 26 ounces. So there are some various reasons that you might choose one or the other. I might use just plain old division to figure out, is this one actually a better deal? Because again, I used to go to the store and think, oh, well, the bigger one is always a better deal because they always charge you a little bit less per ounce. So another way to think about using division, those of you that know me well, Dr. Popelka, know that I drink a ton of Diet Mountain Dew, like an absolute ton of it. So I buy lots of 12 packs of Diet Mountain Dew when I go to the store. And so let's just say that, and I realize this is a really expensive price for Diet Mountain Dews, but I'm just going to use this as an example right now because it makes the numbers nice and easy. If the pack, because they come in 12 packs, of course, we all know that. 5, 6, 7, 8, 9, 10, 11, 12. Let's say that it's $6. Well, if I want to know just how much I'm paying for each Mountain Dew, I take that $6 and I divide it up. I do 6 divided by 12 so that I figure out how much I'm paying for just one of those Diet Mountain Dews. And I know that each Mountain Dew cost me 50 cents. I can use that same idea of division to figure out, in these cases, which laundry detergent is the better deal. Which one is going to be cheaper? Just using that same old idea of division. So I'm going to take this 26-ounce one first. So I'm going to put in my calculator, $9.75 divided by 26 ounces. If I do that, I get 0.375, which we know when we're talking about money, how much is each 1 ounce going to cost us. So we know that money doesn't have 3 decimal places. So that's going to be pretty close to 38 cents. I use that 8 to round the 7 up because it's 5 or bigger. Then if I figure out the price for this one, I do $7.50 divided by 20 and a half. Again, I'm just using my calculator right now. And I get kind of a messier decimal. I'll write the first few 0.36585. I'm just going to round it to the second decimal places. That 5 is 5 or bigger next to the 6, which means I'm going to round this up to about 0.37. So this option is 38 cents an ounce if I'm rounding, and this option is $37 an ounce. So for which is the better buy, remember that right now I said you don't necessarily have to have the most mathy reason like I did. I personally would write that the $7.50 one was cheaper because it's 37 cents an ounce. But we haven't necessarily, and you might remember how to do that from 6th grade. If you don't, have no fear. As long as you justified your reason, how do you know you're okay for right now? Again, some people might have said, well, I'm just going to buy the 20-ounce one because it's cheaper. Some people might have said the 26-ounce one because they believe, turns out mistakenly, like I used to believe, that the bigger the box, the cheaper it is per ounce. But just justify your reasoning for now for number 2, and you'll be all right. So what I just did when I answered that question, the more, for lack of a better term, mathy kind of way, is that I calculated the unit rate for each of those boxes of detergent. And you might recall from 6th grade that a unit rate is a rate with a bottom term of 1. Let's put into kind of numbers to make sure we understand what we're talking about. So in my Diet Mountain Dew example, I'm going to stick with that one just because it was nice, easy numbers. So I paid $6 for 12 cans of Diet Mountain Dew, and I wanted to find out just how much 1 can was instead. Remember, this says a unit rate is a rate. For those of us who don't recall what a rate is, it's just when you have a ratio that has 2 different units. So in this case, I've got $6 is one rate, and then 12 cans is the bottom measurement. So dollars per can is a rate because it's a ratio using 2 different units of measurement. And a unit rate has a bottom term of 1. The word unit, I don't know about you, but I certainly think of the word 1 because unit is a singular word. So that's a good way to remember that when you're talking about the unit rate, that's what you're talking about. So instead of figuring out what 12 cans were equal to, I figured out how much 1 can cost me. So that's where the division came in, because I did 12 divided by 12 to get 1 can. In other words, I scaled down. I went from 12 cans down to 1 can. So then to scale from 6 cans, I also had to do divided by 12. And 6 divided by 12 is 50 cents. So basically, I scaled $6 for 12 cans down to 50 cents for 1 can. Down below is a little bit more of a visual example for those of you that are more visually oriented. And it says, Marta estimated a unit rate this way. She drew an estimate. She didn't actually figure out an exact number, and in a lot of time, estimates are perfectly fine to do. You might recall from the previous example, so she said the first one is about 25 ounces for $10. So let's look back up there. And that's pretty true. Okay, 26 ounces for $9.75. Well, that's a pretty close estimate of 25 ounces for 10. That's pretty close. And they've drawn a little diagram here so that you can see. And she kind of scaled down in her head, if you think about it. So she drew a little diagram here with all 25 of the ounces laid out. The diagram tells you that right here, that 1 ounce is represented by 1 little rectangle in the figure. So if she's paying $10 for 25 ounces, notice here in her head, she kind of scaled down. And these are nice, easy numbers to scale down by. She scaled down from 25 to 5, which of course, we're scaling down from 25 to 5. We know we're scaling down by 5. Then she scaled the bottom down by 5. She scaled the top down by 5 as well. 10 divided by 5 is 2. Then she did a little bit more scaling down by 5 again. She did 5 divided by 5 to get 1. And then she did 2 Remember, when you're scaling up and scaling down, you have to scale up and down by the same number. So she scaled the top down by 5. So she realized that she's paying around, now this is just an estimate, because remember, she rounded from the original problem, but it's still pretty close to 40 cents for 1 ounce. You might recall that that's pretty close to the estimate that we got before. So 40 cents for 1 ounce. So again, I just kind of made this a little bit bigger so we got a better picture. So again, she estimated, and she, instead of $9.75, she changed it to $10, and instead of 25.5, she changed it to 25. But so it's just an estimate to make it nice and easier to work with. And then she scaled down. Instead of $10, she scaled down by 5. And here she scaled down by 5. So that if it's $10 for 25 ounces, that means she's paying $2 for every 5 ounce. Then she scaled down again. And these are still nice, easy numbers to see, because you can tell if you scale down from 5 to 1, you're dividing by 5. So to scale from 2, you got to divide by 5. And that's where she got the 40 cents. Now, the estimate that she got for the second one, again, she changed the totals a little bit. She estimated. So now she changed it so that instead of, she just rounded it to some easier numbers, so that the second one, the smaller one, was pretty close to $7, and you got pretty close to 21 ounces. And again, she scaled down, because she doesn't really care how much 21 ounces are. She wanted to figure out how much it was just for 1 ounce. That's how you really figure out which one's cheaper. So you can see here, from 21 to 3, she scaled down, dividing by 7, which means she scaled down the numerator, dividing by 7. Then she scaled down again to go from 3 to 1. She had to divide by 3. Up here, she had to divide by 3. So that means in the smaller example, she was paying around 33 cents an ounce, according to the estimate. Now you're going to notice that was a little bit different from what I got, because when we estimated, it kind of changed things up a little bit. It didn't change the numbers by a ton, but it did change them by a little bit. And sometimes that happens in real life. So you can tell there's not really a huge difference between the two, but just like mine, where I did the exact numbers in the estimate, the smaller one was actually a cheaper price too. So if I zoom back out here, after we did the scaling down, so in the first one, she was paying, and again, just estimating, she was paying about 40 cents for an ounce, whereas with the smaller box of detergent, she was paying about 33 cents an ounce. Remember that we found the unit rate, or at least an estimate of the unit rate. And again, the unit rate is when you have just a 1 in the denominator. Okay, unit makes us think of the word 1. And it makes sense to figure out which one's cheaper. I don't care much 25 ounces cost. I want to know how much I just paid for 1 ounce. Same thing here. I didn't care how much 21 ounces cost. I want to know how much 1 ounce costs. So that helps me to figure out the better buy. So again, just like when I did it in the more mathy way, our estimate found that the smaller box was actually cheaper. Now let's look and see. It says Brad estimated the unit rates a different way. Now he still used the same estimates, but he drew his picture a little bit differently, which is okay. So let's take a look and see what he did. So he said that he gets 25 ounces, and instead of, remember that in the girl's picture, each one of these represented an ounce. Well, now he's using them to represent $1. So right away, something's looking a little bit off to me. Let's see. So let's see if he's got, because I see 2 pictures that actually have the same numbers. So he probably goofed, but let's see here. So he's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dollars. Okay, so that part makes sense. So if he's paying 25, or if he's getting 25 ounces, whoops. So if he's getting 25 ounces for $10, looks like he scaled down. He scaled down from $10 to $1, which is okay to do. He scaled down from 10 to 1. Of course, to scale down from 10 to 1, you divide by 10. If he scaled down, he has to scale the top down by 10 also. So that gives us 2.5. Okay, so far I get it. So that means that each one of these little dollars is getting him 2.5 ounces. So he found the unit rate, but he kind of switched it up and found the unit rate. The bottom is the money instead of the top, like in the previous example, which is okay. So he found the unit rate. So you got to think about it a little bit differently. For $1, you're getting 2.5 ounces of detergent. Okay, now we know something's wrong here because he's got the wrong picture here for this second example. So what he should have had is 7 of these little dollars. 1, 2, 3, 4, 5, 6, 7. Yeah, he's got too many. And for 21 ounces, he should have, so really this picture should have a 21 up here at the top. And then we should only have 7 of these guys right here. But it looks like, if I'm not mistaken, his math, I'm going to scroll down here. His math is correct, though. His picture is just not right. Because here he started off at 21 ounces for $7. And he scaled down to $1. To go scale down from 7 to 1, he divided by 7, which meant he had to scale the top down by 7. So 21 divided by 7 means that here he gets 3 ounces. So because he got 3 ounces for $1 versus in the other one he only got 2.5 ounces for $1. This one is still the better buy. He's still getting, even though he did it a little bit differently, and even though his picture here wasn't correct, he still did the right thing when he did the math. Because you look right here, and again, in case, because we've forgotten a couple of things from 7th grade. So he started out with 21 ounces for $7. Remember, the point of a unit rate is that you want to find out not how much we get for $7, but how much we would get for $1. So we scaled down by dividing by 7. And then 21 divided by 7 means we got 3 ounces for $1. So then here, this is where it's asking us to, as I said, they both chose the second one as the better buy, but which one of them is reasoned correctly? And this example, or this reason, is totally good. They both actually did the math correctly. Her unit rates just showed the amount of dollars per ounce, while his unit rate showed the number of ounces per dollar. So look back up at her example. All they did was that she put the number of ounces in the denominator, whereas he put the dollars in the denominator. And really, now normally what we do is the version that she did, where you actually put the money on top to find out how much it would cost you for 1 ounce or 1 count of Mountain Dew. The way he did it isn't necessarily wrong. It's just not necessarily the way we would normally see it. Normally we see it the way she did, where you put, again, the money in the top and then the number of items that you bought in the bottom. So that is basically what they're saying here for the answer, that they both did it correctly. However, Brad drew an incorrect model. That's what I was mentioning right here. This should have been a 21 and a $7 instead. But they both still actually did their math correctly. Then right here, calculating the unit rates for each one. This is the math that I did back at the beginning. I did 975 divided by 26. So now let me show you, again, just remind you what I did right in the opener. So the other one cost us $9.75 for 26 ounces. So basically what I did is I scaled down and I found a unit rate. I didn't really care how much 26 ounces cost us. I want to know how much 1 ounce costs. So I went from 26 ounces to 1 ounce. So I scaled down by 26, because the only way I can go from 26 to 1 is to scale down, dividing by 26. So I divided the bottom by 26, or the denominator, which means I need to divide the numerator by 26. So that's where I got that original answer of 0.375, which I actually rounded to 0.38, because, of course, money only has 2 decimal places. Then for the other unit rate, I did 750, and it was 20.5 ounces in the original problem. Okay, so again, I didn't care how much 20.5 ounces cost. I wanted to know how much just 1 ounce cost. So I was using a unit rate. I was using a rate with a 1 in the denominator instead of any other number. So I scaled down from 20.5 by dividing by 20.5. If I divided the bottom by 20.5, I had to divide the top by 20.5. And that's where I got my original answer of somewhere around 0.366, which I rounded to 0.37, or 37 ounces. So question number 5, saying using the unit rates, is it now possible to determine which one is a better deal? And yes, we've actually established in a couple of different ways that, contrary to what you might think, this happens a lot, the smaller bottle was actually the cheaper one. A lot of the time we think that they make the bigger box cheaper in order to make us buy more stuff, but sometimes they fool you, and it really is the smaller box that's cheaper. So now we've got some practice problems where it's asking us to find the unit rates for each item. Again, a unit rate is when you've got a 1 in the denominator. Right now, this says a bottle of 250 vitamins costs $12.50. So I would set that up as $12.50 for 250 vitamins. I'm trying to find the unit rate. So in other words, I don't care how much 250 vitamins are. I want to know how much just 1 vitamin is. So to go from 250 to 1, I have to scale down. I have to divide by 250, because 250 divided by 250 is 1. If I scale the denominator down by 250, I scale the top down by 250 as well. Even I'm not going to try to do this in my head, that's for sure. Okay, so when I do that, I get 5 cents, 0.05. So that means it costs me 5 cents for 1 vitamin. So the unit rate is 5 cents per 1 vitamin. So that is my unit rate. Again, I don't care how much 250 vitamins are. I care how much 1 vitamin is. You guys go ahead and pause the video. Go ahead and try B on your own. See what you get. I am going to have assumed that you followed directions and that you paused the video and you go ahead and try it. So it says a pack of 40 batteries costs $25.95. So that'd be $25.95 for 40 batteries. Again, it's asking us to find the unit rate, so I don't care how much 40 batteries are. I care how much 1 battery is. So I'm going to scale down from 40 by dividing by 40. So if I scale my bottom down by 40, I also have to scale the top down by 40. So if I do 25.95 divided by 40, because if I scale the bottom by 40, I got to scale the top by 40. That gives me kind of a jacked up decimal, 0.64. I'm going to leave it at 0.648, because since it's money, I really only need to do the first couple decimals. And I know that 8, because it's 5 or bigger, is going to round that 4 up. So it's really 65 cents for 1 battery. So that's my unit rate. Part C, go ahead and try it yourself. Pause the video restart the video when you're ready to check your answer. I'm going to go ahead and work it. So it was 16 and 16.25 for 24 rolls because we're finding the unit rate. I want to know how much it was for one roll, the unit. I scaled down by dividing by 24. If I scaled the bottom down by 24, I've got to scale the top down by 24. So 16.25 divided by 24. I'm just going to write the first few decimals here. It's 0.677. That 7 is going to round up. So that means it's going to be 68 cents per one roll for my unit rate. For D, pause the video and then go back and start it when you're ready. I'm going to go ahead and assume that you have paused the video and now you're ready to check it. So $19.95 for 500 cards. I don't care how much 500 cards are. I'm finding the unit rate. So I want to know how much one card is. So I scaled down, dividing by 500, which means I need to scale this part down by 500. I get 0.0399. Because we're talking money, I'm just going to use these first two decimal places. That 9 is going to round that 3 up. So that means it's going to be 4 cents for one card. So 0.04 for one card. Go ahead and look at number 7. Pause the video. Try to work it out yourself. I am going to go ahead and assume you've done that you've paused the video, tried it out yourself. So it says determine which one's the better buy and make sure you're explaining your reasoning. So I've got an option of $1.97 for 22 vitamins. I'm going to scale down to one vitamin. I'm going to do that by dividing by 22. If I divided the top, or the numerator, sorry, I'm terrible about that. I need to call it the numerator. So if I divided the denominator by 22, I need to divide the numerator by 22. Gives me kind of a messed up decimal. It's 0.089. I know that because I'm talking money, I just need these first two decimals. So if I round it, it's going to be around 9 cents for one vitamin for the unit rate. The other one says $3.25 for 40. I'm going to do the same thing where I'm going to scale it down. To go scaling from 40 to 1 means I need to divide by 40, which means I need to divide the top by 40. So this one is going to be 0.081. Again, I just need to round those first two decimals. So in this one, in the first one, the 9 rounded that up to 9, but this 1 means that it's just going to stay at 8 cents for one vitamin. So not a huge difference, but the second one is still a little bit cheaper. So if I'm explaining my reasoning, I would say that this one is 8 cents for one vitamin, while this one is closer to 9 cents for one vitamin. So the 40 vitamin pack is the better deal. If I'm looking at B, again, I'm assuming that you've paused the video. I've got $8.76. Oh, we've got some messy decimals now. For 32.6 ounces. If I'm trying to figure out I misread the question. Oops. It's 24.3 ounces. Sorry about that. So I don't care how much 24.3 ounces are. I want to know how much 1 ounce is. So I've got to scale down. To scale from 24.3, I divide by 24.3. If I divide the bottom by 24.3, I divide the top by 24.3. All these messy decimal. So 876 divided by 24.3 means that I'll be paying about 0.360. I'll just round it to 0.36. So 36 cents for 1 ounce. And the other one, I've got $16.95 for 32.6 ounces. I don't care how much 32.6 ounces are. I'm going to scale down by doing 32.6 divided by 32.6. So I'm going to scale down, which means I'm going to scale down up here. So 16.95 divided by 32.6 means it's going to be around, it's 0.519. So I'm going to round it to those first two decimals, which will be 0.52. So this option is definitely, the 24.3 ounces is definitely the better deal because I'm getting 1 ounce for 36 cents, whereas in this other one, I'm getting 1 ounce for 52 cents. So I'm paying a lot more per ounce. So the 24.3 ounce one is the better deal. For our last one, it asks us to find the unit rate for each of these bottles. So for the first one, if it's 39 cents for 12 ounces, for the sake of space, I'm going to not label, even though I know that that really means 39 per 12 ounces. Normally I would label those ounces. So I'm scaling down from 12 to 1 by dividing by 12, which means I need to do 39 cents divided by 12, because if I scale the bottom here down by 12 to go from 12 to 1, I need to scale the top down. So this is going to be, if I'm rounding, 3 cents per ounce. Oh, oops. First it says, my fault, it says to write each as a ratio first. So let me go back and fix that. Well, I guess actually I did that. Never mind. I really kind of already did that. Because I did 39 cents per 12 ounces. So that is a ratio. Then I scaled it down so that it was the unit rate. So I'm not going to put my units in there just because I'm kind of running out of room a little bit. If I round, this is going to be 0.3 or 0.03 cents per ounce. So the ratio for the first bottle is 39 cents per 12 ounces. Then if I scale it down, it's about 3 cents per 1 ounce. Bottle number 2, it's 57 cents for 24.3 ounces. If I scale that down, so I divide by 24.3, so I've got to do 57 cents divided by 24.3. Man, these decimals stink, don't they? So if I round that, it's going to be about 0.02, so 2 cents per ounce. So again, this is bottle 2. This is bottle 1. For bottle 3, I'm going to do 70 cents per 33.8 ounces. I'm going to scale down to 1 ounce by dividing to go from 33.8. I divide by 33.8 to scale down to 1. So if I do that, if I round, it's about point. Again, if I'm rounding, this one is also around 2 cents an ounce. So that's bottle 3. I'm going to, so that I've got them all on the same page since I'm kind of running out of room here, I'm going to put bottle 4 up here at the top. So it's $1.39 for 128 ounces. If I scale it down to 1, I have to divide by 128. So if I do 1.39 divided by 128, if I round it, it's about 1 cent per ounce. So in this case, bottle 4 is the best buy because for bottle 1, I'm paying 3 cents for 1 ounce. Bottles 2 and 3, I'm both paying approximately 2 cents per 1 ounce. For bottle 4, I'm only paying, for bottle 4, I'm only paying 1 cent per ounce. So bottle 4 is the better deal.